Uh, Today's session is based on a topic related to manufacturing field itself, that is Inventor, making which is making AEC construction industry uh, easy to use using a workflow from BIM to Inventor, building information modeling using this Inventor software. So my name is Adarsh and I am a technical engineer at Bimlabs. So let's start directly into the topic. So uh, before that, this is a company profile. So Bimlabs Engineering Services is a company mainly focusing on the technology known as BIM. So some may know about BIM, but I hope this whole session is meant for mechanical students, so they may not really know that what actually BIM is. I will just brief it in the next slide itself. So this company is mainly focusing on the AEC industry, construction industry, and location is in Kerala, India. We are a Autodesk learning partner and a member of Indian Green Building Council. So our business areas are mainly training for students. We are working as a finishing school for students and corporates. So we provide project outsourcing and also placement services for students. So this is the content for today's webinar. You would be going through what is AutoCAD Inventor interoperability, and then an intro to what is Autodesk Inventor, then REVIT BIM content creation. These whole topics would be covered in today's webinar. So what is BIM? So mechanical students, electrical students may not know what BIM is. So BIM, the full form is building information modeling. That is, it is a process of creating this whole building, say bigger than 5,000 square feet. So creating that building needs a lot of information, and the plans and what all information put into it, say which material to use, which equipments to use, which how components need to be modeled, the 3D rendering. We need to see what it actually would look like in front of us when it is created. So virtual prototyping and all can be done using this building information modeling technique. So building information modeling is simply a collection of set of softwares to assist AEC, the construction industry. So one software among those in which mechanical students are related is Inventor, Autodesk Inventor. So Autodesk Inventor is a CAD application. It is a mechanical 3D design, simulation, visualization, and documentation software. So you may or may not have heard about this software. You may have heard about SolidWorks, CATIA. One among them is this CAD/CAM application known as Autodesk Inventor. So Autodesk is the parent company of this Inventor software, and in this software we can design components for the whole say product design, industrial equipments, etc. can be designed, and this uh, model, this virtual prototype, can be used to simulate the original model, that is which we are going to create. So this is what we are going to do in Autodesk Inventor. So in this the whole Autodesk is a platform where there are its different n number of software. So there is a interconnection between each and every software. For product design and manufacturing itself with BIM, there is a collection of softwares inside this Autodesk in a platform itself. That is, Revit is a software for creating 3D model of a building. Fusion 360 is a product design software. It is a cloud-based software. That is, the models that we create can be made using the help of the whole team. That is, one part may be created by one team, then another part, one member in the team, then another part would be created by another member in the team, and the whole thing is done in cloud. What is cloud? You can simply say what Google Drive is. So designs are stored online and they can work online itself. If people are staying in different locations, say now it's lockdown in our area, so people are staying at different locations, they can work in a single software itself from different areas and work on a single project. So this can be done using Fusion 360. So Inventor is a standalone platform in our computer itself, where this is also, this Fusion 360 and Inventor both are a product design and manufacturing software, that is a CAD CAM software. And AutoCAD is a drafting software. You may have learned engineering graphics during your, say, I'm hoping that you are engineering student, so you may have done engineering graphics. So that's a very 1 second. Okay. So you people may have done drafting, that is drawing in a canvas during your engineering graphics period. So at those drawings, 2D documentation purpose is done using AutoCAD software. Then Inventor, AutoCAD and Revit, all these have associative link. What is an associative link? That is, we can reference each and every files from these softwares into one another, so that any changes made in a single software is being reflected in the other one. So this is the interoperability between the these softwares. So this is only product manufacturing collection. This is only a brief, but there are a lot of other products also. That is, AutoCAD itself has its fabrication products, that is CAD MEP, CAMDuct, estimation MEP, those softwares, as well as these say analysis softwares, etc. Those all have these, what we say as associative link. There are competitors for them, but still the interoperability between Autodesk Autodesk software is much better than others. So I hope you got what I said, and I'm getting into Autodesk Inventor itself to show you what we are going to do today. So just show you the interface. So I hope the Inventor user interface is in front of you, Autodesk Inventor. Can you see that?
Yes.
Okay. So this is the product that I have mentioned, the software that I had mentioned, that is Autodesk Inventor. So this is the CAD software that we are going to discuss about today. And as you can see, this is a model of a plug valve. This is the one which we are going to deal with today. So this is going to be exported to a family file, that is Revit is a BIM software, building the a software to make the design of a building. So we need our manufactured components to be appeared in the building process itself. They need to allocate spaces for our components. So we would develop the model in this software and transfer that, export that to BIM, so that it can be used. Manufacturers can send directly the data to the construction industry, so that architects or the structural engineers can work with those. So this is a whole software itself, and here you can see, when I take the case of a new file, as you can see, there is now I'm using a metric standard for my project, and I'm going to create a standard .ipt file, that is a part file which has the units uses So I'm going to create this one. So in this whole thing itself, you can see here there is a browser. There are two browsers. Yes, here I am just telling you about this one, that is model browser. In this one, viewmaster and all. So in this browser, we can select each of the plane that we are going to work with. So this is the use of this browser, and this is the whole history. This would become the history of the whole process of part development. That is, when we create a part, each of the steps would be added to this library over here. So so if we need to start a sketch, this is a tab for 3D modeling. This is a tab for sketching. This is for annotating. Annotating is the making dimensions in your model. So then inspect tab, whether you need that model to be inspected for any analysis or that section surface, or that needs to be inspected, that can be done in this one. Tolerancing can be done. Tolerancing is the process where you may have studied geometrical dimensioning and tolerancing, or you may have heard about it. So geometrical this dimensioning and tolerancing is where we provide dimensions, but the actual that machine, say we have additive manufacturing and subtractive manufacturing. In subtractive manufacturing, what we do is, if we need to cut, they say, I'll just draw a single drawing and tell you what it is. So in this sketch, I'm having two circles. So okay, this is my sketch. So in this sketch, as you can see, there are two circles, but the machine, how much it would be accurate enough to cut this portion uh, is not viable. So this whole thing needs to be cut in this portion and this portion. So I need a hole at this portion and this one too. So if there is a mismatch in the dimension, say the part, this circle is being cut, say, 1 second. Say the machine was not able to cut the whole thing with this dia, and it had there was a tolerancing difference, that is a plus or minus value difference in which the cut has been made. That would be reflected in our model. So the gap between these two circles would also be affected with the tolerancing issue. So while constructing a product or while manufacturing a product, this whole concept of geometrical design and tolerancing is of relevant use. If not, there would be dimensioning issues where we would produce a model which won't be, when duplicated, won't be the replica of the earlier one. There may be a shift in the whole thing. So those things can be done while tolerancing. And then we have the tools panel where we have material, appearance, etc. Say if we have created this part, say I need to need this sketch to be extruded. See, so I had extruded this sketch. Okay, and this is my sketch which has been extruded. So if I need any material or appearance to come, I can use this option. Say I can go for any appearance changes, and it can be applied to this model. Okay, like this. So we can provide all the material, appearance and features, and we have the document settings, everything, that is units, sketch. Say we need to take the bill of the material, this material is made with silver or with any other thing with the specified rate. We can do so with clicking on which one is having which amount, and we can provide which is the quantity required and which is the base unit that we take, and specify that unit and how much bill cost that can be uh, made using this bill of materials, then tolerancing value as I mentioned. So this is what is for the documentation settings, and we have also application options that if we need any performance upgradation we can do so. This is having now a performance tuned, so if we need a basic tuned performance in this one we can also use that. All these, this application, the whole inventor application can be used, can be controlled using this application option. So uh, this was what is about tools panel, and then we come to manage panel. In manage panel we have a set of options which is of use, much use, because this has the iPart feature, then making components, then adding parameters. So parametric models are of great use in today's industries. Everything is made parametric. The drawings that you have made in your college, that is in your college you may have made connecting rods or say any screws, nuts, etc. That would be they would provide a dimension and you would make what they have told. So dimensioning is important, but if there is a relation, say one this breadth of this solid, say this breadth needs to be three times of this height. So this breadth b is equal to say 3 centimeter, and this height is equal to 2 centimeter. So we need three times the sorry. So if height is 2 centimeter and we need to calculate the breadth, we can do so by keeping it as a parameter, and we can multiply by 2. The whole software would multiply by 2 and add that parameter to our model, creating this a parametric model. So we add certain parameters to help make this model. So what iPart is, we need rules to be set. Say I had made this hole. I mentioned about iPart, so I'm just briefing you about this one. Say I had made this hole. So this hole needs to be say if there is two holes now. So if I need to make a cut between these holes, I need to just draw a shape, and I need to make a cut from here to here. So in between I can get a cut. And if I have three holes, I need to have two cuts between each of the holes. That can be done using this iParts. That is, if a certain feature needs to be replicated while changing any parameters in this model, that we can do by using an iLogic. So creating an iPart is easy to use in different say different scenarios. Say we need to create a bolt, and that bolt need to be used in different projects. So we can simply make that as a iPart and drag and place the component to different projects. Say we need not make it again and again. We can just use that one itself and place that one in the model. So this is what iPart is. I hope you understood it. If not, you can tell me. I was a bit fast, I think. Hello. So, okay. So then view tab is for controlling the whole view of this interface. Say we can manipulate the user interface features. Then if we need to clear the screen, that we can do so. Then we have this navigation wheel for navigating inside the model. Say we need to navigate, we can use this to zoom in and zoom out, say rewind or part creation, that all can be done using this navigation wheel. And this is the whole use of this view tab and environments. Today what we are going to discuss is about this environment tab. So this has different environments in which inventor can work and have different workflows. So one among them is the bin content, and we'll get into it later. So this is basic features, and collaborate tab is for collaborating between teams. That is, if we make a design and we need different members in our team to work on the same design, we can do so by uploading it to a cloud platform for inventor, that is configurator. We can upload those design and someone another one can review and comment on those design. So this is what this inventor collaborate tab is for. Simulation is for having any simulation. Say I have integrated Autodesk CFD in this one. So Autodesk CFD is mainly for this CFD simulations, computational fluid dynamics simulations. Say we need to build a building and we need to know the heat and cooling loads, airflow, etc. That can be done using this simulation software, that can be simulated using this simulation software. So let's jump into the actual thing. So I'll just share the screen of PPT itself. If I am going too fast, just tell me. So that was a CAD CAM software, and so first one, what I had mentioned was invent the interoperability. That is, we can operate between different software. So BIM, as I told, is a collection of different software. So 2D documentation, that is 2D drafting, may be done in a software like AutoCAD, and we need to retrieve that drawing to work with in Inventor. That can be done using the associative link between this Inventor and AutoCAD with the use of AnyCAD feature. So AnyCAD is integrated now into Inventor from 2016 itself, but it has a much more feature in 2021 version. So it has the capability to keep a REVIT file as a reference. So 1 second, I'll just open REVIT and show you what it looks like. So this is the one that we had discussed about. This is a this is a building information modeling software that we use for creating designs of buildings. Also mechanical, electrical, plumbing systems, say structural work. What we are interested is for the mechanical one. So say this, I'll just open a new one. So just also new template, and so this is say Revit. Now if we make anything in this one, we can use this file as a reference. Say we create walls in this model. So, 1 second. It's taking a moment. So if we made this as a reference wall for our equipment, so kindly mute the audio. Yes. So, okay. If we need this wall as a reference for our model, say now if we go to 3D, we can see this wall. If we need to give this wall as a reference for our Autodesk Inventor model, say we are going to create a AHU, that is air handling unit. If we need to give a space for our model, we can do so by referencing this room in our inventor file. So now it's possible in 2021 inventor, it's possible to make this reference. I hope this is clear to you. And if now we are going to see what AutoCAD interoperability is. So this is my AutoCAD file. Can you guys see it?
No.
Can you guys see it?
No.
AutoCAD
Yes, yes.
drawing.
I can see your screen. AutoCAD screen.
Okay, okay, okay. So just refresh. So this is the AutoCAD file that we have. So in this one, I had just made a rough sketch. It is not a mechanical model, just to simply tell you what the interoperability is. So there is going to be that course means on this one itself, the whole inventor itself. It would be a 5-day course, which would be told later on itself. So by the way, if you need a certificate for this webinar, you would have to pay an amount of 200, I think. So that note needs to be paid, and those who need those, that is Autodesk certification, you can directly contact me. I would provide my contact at the end of this presentation. So let's get in the topic itself. So this is the AutoCAD file I have. So I need this to be referenced in my inventor. That is, I need this AutoCAD to be used in inventor. There is a workflow between each of the softwares. So now my workflow is I'm going to take this AutoCAD file to my inventor. So I'll just switch to inventor. Since we are showing about different softwares, it would be a lag for you in your screen itself. So pardon me for that. So just close these. I hope the inventor screen is in front of you. Can you guys see it?
Yes.
Okay. So we have this say now what we are going to do is we are going to work with this inventor to get that drawing into this one and use that geometry, and I'll show you what associative link is. So in this one we have the manage tab. As I mentioned, there's a manage tab, and in this one we can say one second. Now create a new file. I'm going to create a new part. So I'm going to go to standard IPT, and now I'm going to go to the manage tab, and there is an option to import. This import feature is built in with AnyCAD. So AnyCAD is going to going to make an associative link with our software. So this one is the model that I have. This is the rough drawing that I had made. So I'm going to open this one inside Inventor, and here you can see we can select in which plane should I need to place a model. So this is the planes that we have. and I can just select the plane which I need, this one or this one. Say I'm going to place it on the XY plane. I'll just click on this one, and we need to select the origin where we need to place this model. Since this is a small model that I had made, it would be coming, as you can see, inserting an AutoCAD drawing creates an associative drawing underlay. That is, we can simply make drawings you may use as a reference, or we can have an associative link with the original file itself. That associative link is what we are interested for. So now it's made. See, look, this is our drawing. So I can click on these one. If I need to make say, this is only a drawing file that we have imported, so in reference of this one we need to create a sketch. That is, we need to use these elements to create a 3D model. So for that, we would go to the sketch tab, and in this one we need to start a sketch. Say, I'll just start a 2D sketch, and I can go and select which plane I require. Since this is a small model, it is being the planes are being shown very small. So I had placed my model in the XY plane, so I'm selecting the XY plane itself. So this is my XY plane, and in this one I'm going to say, this is my that model that I had made, that drawing I had made. So I'm going to make sketch using this drawing that I have. So in this one, you can see different options in sketch itself: project geometry, project cut edge, project DWG geometry. So if I select project geometry, it would use the project's geometry. This one is our project. So this file is a linked file which has been taken from another drawing. This is not a part of Inventor. So the things that we may have made, that is, if we sketch a circle in Inventor and click on this project geometry, we can select those. But at the same time, if we try to select an AutoCAD file, we cannot do so. An AutoCAD file is a reference file, and what we need is a project DWG geometry. In this project DWG geometry would help us use this to project these things. Say, now you can see this has been highlighted with a yellow mark. So this means that we have used the reference sketch to do so. So to make a model. So now we'll finish the sketch, and now if we go and try to create a 3D model, we can do so as we have a sketch. So we can directly click on this one, say, and do whatever extrusion we need to do, that we can do. So I'll just click OK. And in this also, you may be thinking what associative link is. We have just created a geometry using the referenced model. That was the only part. But at the same time, I'll just switch to AutoCAD and show you what associative link is. So in this one, so now I hope the AutoCAD window is in front of you. So in this file, as you can see, there is these circles that we have made, and if I need to change the circles dia, say I need to change the circles dia to this much, and I am going to make a line which would be connecting these two. Say, I would be doing so, and if I save the file, say, and go to Inventor, say I go to Inventor, Sorry, there was an internet issue going on here. So sorry for that for shortly. So in this one, say hello, can you hear me?
Yes.
Okay, sorry for that. So just say the file. 1 second. There's a power shortage going on. Sorry for the delay, guys, but the update option is not being updated. Wait a second. So sorry. Now the error has been fixed. So there was an error in my PC itself. So the whole thing was not saved properly. So now you can see this is the update portion option. So in this one, if we do a local update, you can see that our model has been updated. Say this is our file, and you can see the sketch that we have made is updated to our model. So sorry for the delay caused. This is a problem that is going with my PC. So this is what an associative link is. That is, if we do any change in the existing file which we have linked, that would be replicated in this one. So I'll be going in a fast pace right now. I hope this one was delayed a bit. So I'll just switch to PPT, and 1 second. So next thing is this Inventor to RFA file. That is, I had already mentioned you that Inventor can be used in creating RFA files, Revit family files. Revit families are those like, say, a plumbing fixture. Plumbing fixture is something like a, say, bathtub or a sink. That is a plumbing fixture that needs to be used in a building, so that the manufactured model, the design model, needs to be used in the building so as to know what space it takes inside the building. So if we need to do that, we need to create a model in Revit or use the existing model of the manufacturer in Revit as in Inventor, and use that thing in Revit so that we can know how much space it would actually take. That Inventor model would have n number of features which can help the to make to see accurately which amount of space is going to be taken by that uh, object, since there are more modeling features in that. So what in this workflow, what we are going to do is using an Inventor assembly which we have, that is a plug valve. We are going to simplify that model and provide a unified coordination system, universal coordination system, and then provide an iLogic and export it. So iLogic is a session, as I had mentioned, iLogic is creating logical parameters. So it needs a bit of knowledge in this VBNet coding and all. So it would need another session to be discussed in a lot detail. So we would be discussing these workflows. So by this itself, we can export. If any parameters require that logic, we can use the iLogic to do so. So in this one, so I had told you, family is a group of an element which is having a graphical representation. That is, if we take the case of sink, there may be different types of sink, but the whole sink maybe there may be two pipe sinks, say kitchen sink, say this toilet sinks, but all have the same hierarchy. That is the it is a sink family, that is a plumbing fixture family. So now when we see Revit, we can see so we switch to Revit. See, I'll share the Revit screen. In this one, if we import this plumbing fixture, say I open this one, this M bathtub. You can see this is the model of a bathtub. This is the model of this bathtub. So this is a realistic view in Revit, and this is the one that is made in Revit to be replicated in the building itself. So this model has certain parameters like which type of bathtub is this one. This is, it is a, if it is a, it needs hot water, it has a pipe connector for hot water. If it is a, it needs cold water pipe, then we can have that too. If it needs sanitation, that is the wastewater needs to be pushed out, so that can be done. All these parameters can be adjusted in the parameters tab of this family. So this is the graphical representation, and these are the parameters that the two creates a family. So we are going to create the same using Inventor workflow. Say I have this I hope the Inventor screen is in front of you. So I have this plug valve like this one. So in this one, say this is the assembly made. So as you can see, this is the assembly, and it contains a lot of details. Like we can rotate these parts. We have this part. We have a void, that is a hole in this one. See, if you rotate, we can see there is a hole. But the construction industry won't need this much of details. It only requires what space it would take actually after that welding and the whole applying of material, how much space it would take. That is a tolerancing value, bit accurate value that needs to be used to replicate this model inside the building. So for that, we would shrink this model first. This, when I go to my PPT, say my PPT, you can see that we have, as I mentioned, there was a BIM content tab, so environment tab, in which there was an option for creating a BIM content. In that, we would create a family by using OMNICLASS family features and metadata. What is OMNICLASS family? The CSI industry, Construction Specification Institute, has provided industrial standards for industrial unique codes for each of the systems. Say plumbing fixture has a unique code. Say plumbing fixture, in that domestic cold water is coming. Then like say you can see sanitary laundry equipment. It has a sanitary equipment code of this one, and in that inside this one is the actual OMNICLASS code for the plumbing fixture which we are going to create. So each of the thing have different unique codes, that is OMNICLASS family. So this is the construction industry standard to differentiate uniquely between each and every family element. So next is adding metadata. That is, metadata are the attributes. Say we need to provide the description, manufacturer data, say a URL to our product link, or BIM is something which would help in say operation and maintenance. If a thing is going to expire, means it would be faulty within this much year. So we can provide this detail into our BIM model while creation itself, and the level of detail put into it is greater. And using this detail, the owner can use those details to check whether our components are working properly. The BIM this BIM softwares allow them to manage those using the other platforms such as mobile platforms, say Windows platform. They can use those tools to identify if their this components are going to expire after some time. That can be also used by using this metadata function. So this is what metadata is, and this is what we are going to do. I'll just get into Inventor tab itself. So in this one, first we are going to do shrink wrap. So in the environment tab, so in this one, you can see in assemble tab itself, we have the feature for simplification, that is shrink wrap. I'm not getting into the parameters. I'll just shrink wrap and show you, since now you have seen the whole the dismantling of this assembly, and now I'll grab this one. Sorry, okay, 1 second. So since I had changed to 2021 version, the shrink wrap feature, the template has been the template has got some errors. So this is not shrink wrapping. I have a shrink wrap file itself with me, so I can use that as a reference right now. So after clicking that feature, this would be the one which would be exported. That is, this would be the shrink wrap file which we would get. This one, say now you can see the assembly cannot be separated. It cannot be dismantled. So after shrink wrapping, we would get a model like this, and this model can be used to used as a BIM component by going to environment tab and then to BIM component, BIM content. So in this we can add, say we need a pipe connector, so we can do so by adding a pipe connector, say where we need to place it. Say I need a pipe connector here, so I had to place this one, and I need to select which system. Say it is a domestic cold water system, I can select. So the cold water system that we have in our house, that is domestic cold water system. So I'm just selecting that one, and I can select which is it a bidirectional one. I can select which flow direction it has, in or out, that I can choose, and I can choose the connection type, whether it should be coupling or a flanged one or a slip joint. That can be choose from this one. So I'll just click OK, and as you can see, there is a pipe connector fixed here. So this pipe connector and what all features they say we have created, we have said that it should be the direction should be inwards, so that all these parameters that we give would be reflected in our say model. So in our Revit model. So if I go to other building components, I have the ability to add description. Say now it's plug valve, I can just change those, say plug valve 1, so I can do so. Then manufacturer, whether this is manufactured by someone, say Autodesk, that we can do. then URL can be provided, what model it is that you can provide. So that all metadata thing what I have told can be prepared using this one. Then what we need an OMNICLASS family, as I had mentioned, to know to be identified by REVIT that it belongs to certain family. So in this one I have chosen valves, that is say valves for liquid services. Under this supply and distribution of liquids and gases, I had selected this OMNICLASS, and I can simply click on OK, and this has now become a model with certain level of detail. So if I need this one, I can just export this component to a RFA file. I'll just export to a certain folder and show it to you. Since I'm not in the office itself, so I'm using my home PC. It's a little bit delay in this PC, so it's having low capacity. That's why. Since this is taking, say now, okay, we have got the. So I'll share the screen to you. The export has been done successfully, and we have got a report stating that Autodesk has translated our model, and this is the translation report where I had made a Revit family file using my Inventor 2021. My author is me itself, units chosen, etc. Then bounding box, how much would be the box in which this whole thing would fit, that can be also seen here. Then element type, say faces, configuration, family type, if it is a standard one, it is a means component for valve with liquid services. Then we have two pipe connectors which has been produced successfully, that also can be seen. If any another properties are done, that also can be would be reflected in this one. Say we provide iLogic, what I have mentioned earlier. If we provide those, that would also be reflected in this translational report. So if I switch to my window, and if I open that shrink wrapped file, see, 1 second. So This is the REVIT file. This whole thing, my PC is going through much of problem. So the one that has been exported now is being it has been corrupted due to this software issue, and so I have an earlier prerequisite thing itself, pre-set thing itself. So I'll just show that one. This is the model that I had created, and as you can see, I have this pipe connector here itself. The pipe connector that I had made, it is using a diameter OMNICLASS number, etc. can be seen. Now, I go select this one. So you can see it is domestic cold water and flow type, you can see itself. And this can, the properties that we have mentioned are also for this family are also visible in this one. Say identity data, that manufacturer thing that we have mentioned. As you see earlier, I had mentioned these much details into it. So that have also been added to my model, and we get the output like this. So this is the Inventor REVIT workflow. There was a bit of error and delays due to this software issues. So sorry for that. I hope this was clear to you. And I just switch to the slide itself. So as we had done this whole design process, we can use Configurator 360 platform to upload our design to cloud, and then use that by different members inside a team for reviewing and commenting and working with each other. So there is a coming program which is a centrifugal pump using Autodesk Inventor. It's a 5-day online program. I uh, assure you that these issues may be fixed by that time, since lockdown is going down. PC that we are using is from our home, so pardon for that. So 5 days online program is going to be there. You would get an Autodesk certification, and there would be a certain fee for that, so you can check that by contacting us. Then we would have a recorded session, and we would provide the course material too. The contents are advanced part modeling, assembly modeling, design automation techniques, 2D documentation, and exporting to BIM software. This was only a brief of what we can do with BIM Inventor, but there are a lot more